Okay, so our topic today is the inverses of trigonometric functions. So when we were finding our values on Friday last week, you were given like the tangent of 300 degrees, and then you had to find a value on the unit circle or divide the two values for the tangent. You can also find the measure of angles given the value of a trig function by using the inverse trigonometrical relations. So before, when you were doing this, your input was an angle, and now our output is going to be our angle. Okay, so I want you to look at the table, and in our table, our first values are all the values of theta. Okay, so notice here your input is theta, and then for the inverse, that is now going to be our output. So I asked you guys to think about the inverse function. Do you guys remember what happens with your functions? What happens with those input and output values? So here theta is the input. For the inverse, theta is the output. So what happened? Yeah, they're just going to switch. So when we first studied inverse functions, that's what happened. Specifically, we talked about it with domain and range. Remember, the domain and range would switch because the x and y's would switch. Okay, so the difference between an inverse and an original function, we can go ahead and write that down right now. It is just the input and the output value switch. So before, we would plug in an angle and get out a value. Now we're going to plug in a value, and our output or our solution is going to be an angle. Okay? So for this first part, it's called the inverse relation instead of a function. And that's because functions are defined as for every input, there's exactly one output. But on the unit circle, you can have more than one output. So that's why it is not a function. So the input value can have more than one output. The input value can have more than one output. Which makes it not a function. The input value can have more than one output, which makes it not a function. Okay, so for this section 11.7, you are going to be using the first quadrant, okay, and we're only using that part today. Okay, and example 1 says to find all the possible values of finding all the possible values of, and then your inverse notation, if you guys notice here, has that little -1 here. Okay, so that is the notation for your inverse. So for part A, it's the cosine inverse, and that's how you say it. It's not cosine to the -1, you say the cosine inverse. And this is of √3/2. Cosine inverse of √3/2. Okay, so I wrote these down just to help you understand what you're looking for. When you are finding all the possible values, you are always going to find this in radians. Okay, so not degrees, you're going to find it in radians. Okay, and you are going to find the values between 0 and 2 pi radians, for which the cosine of theta is equal to root 3 over 2. So we should remember from last week that the cosine of theta is the x-coordinate. Okay, the cosine of theta is the x-coordinate. Okay, so what we're going to do is we are going to use our first quadrant, and we're going to find where the x value is root 3 over 2. Okay, so look on your quadrant and you find it. Okay, where is it? Yeah, pi over 6. Great. Okay, so we're going to draw a little circle because I'm going to help you find the other one. So there are values on the unit circle that occur more than once. Okay, so we're going to find the one in quadrant 1 first, like we did, pi over 6. Okay, and at pi over 6, we saw that the x value was root 3 over 2. Okay, to find the second place where you have root 3 over 2, we're going to use what we did to make the circle, which is the reflections. So we're going to talk about all students take classes. Do you guys remember what that means in terms of the unit circle? Yes, okay, so it's where all of your values are positive. So everything is positive in quadrant 1. This is the cosine. So the cosine is positive in quadrant 1 and also what quadrant? Quadrant 4. So that's where the other value has to be, is in quadrant 4. Okay, to find out what it is, we just do the reflection. So if I reflect pi over 6 in quadrant 4, okay, it would be right here. What's the reference angle of pi over 6? Pi over 6. So do you guys know what this is going to be? 11 pi over 6. Yeah. Do you guys know another name for 11 pi over 6? Yep, negative pi over 6. We'll talk about that one later. Okay, so part of your final answer is going to be pi over 6 and 11 pi over 6. There's just one more thing we have to do. Okay, so because it says find all possible values, when it says all possible values, that means any rotation of this is also going to be an answer. So if I were to do a rotation, how many radians is that? If I do one full rotation, it would be 2 pi radians. Yep. So what you do to find all the angles that are coterminal is you would, so we're finding all the angles that are coterminal with pi over 6 and 11 pi over 6. Well, what would you have to do to find the angles if they're coterminal? Plus or minus, and then in radians? Yep. Okay, so you have to keep adding 2 pi over and over again. Okay, so if we're finding all of them, we have to come up with an equation. So the equation that we use is, we just say plus 2 pi n, and this is where n is an integer. Okay, so we do plus 2 pi n, where n is an integer. Okay, and n is going to represent the number of rotations and your direction. N represents the number of rotations and your direction. Okay, so there's an infinite amount. So we would not be able to list all of the values because you would just keep adding and subtracting 2 pi. Okay, so instead, all we write is pi over 6 plus 2 pi n and 11 pi over 6 plus 2 pi n. Okay, so this is the form of your answer if you're finding all of them. Okay, so if you did pi over 6 plus 2 pi times 1, that would be 1 rotation around the circle. You don't have to write this down. I just want to show you like why we do this. So 13 pi over 6 would be another place on the unit circle where the cosine would be root 3 over 2. And then if you went in the other direction, if you did 11 pi over 6 plus 2 pi times negative 1, you could subtract 2 pi. Okay, so this is just like getting a common denominator like we did in the past. So pi minus 12 would be negative 11 pi over 6. So that's why we're allowed to just say the n value, and then n is going to be the number of rotations, because there's an infinite amount of rotations that you can do for each of these, and your x value would still be root 3 over 2. Okay, so that's our form. All right, so for this next one, we are going to do the tangent inverse of negative root 3. So the tangent inverse of negative root 3. Okay, so to make the tangents a little easier for you, we're going to write a few more things down on our quadrant sheet that we're using today. Okay, so what we're going to do is we're going to calculate the tangent values for everything in quadrant 1. Okay, so we're going to calculate the tangent values, okay, for quadrant 1. You only have to do it for quadrant 1 because everything else goes from that pattern. Okay, so starting with 0, okay, if we find the tangent of 0, remember, the tangent of theta is y divided by x. Okay, so at 0, your point is 1 comma 0. 0 divided by 1 is 0. Okay, so now we'll do pi over 6. Okay, so pi over 6, you have root 3 over 2, 1/2. You're always doing the y divided by your x. Okay, so we're going to keep, we're going to change, we're going to flip. Okay, and then I want you guys to simplify that. And then we're going to find pi over 4, pi over 3, and pi over 2. Yep, on the sheet. Yep. Michelle, you're writing this down somewhere. pi over 4 is my favorite one because you divide something by itself and what do you get? 1. Okay, so we should have root 3 over 3, 1, and root 3. And then at pi over 2, you have 0, 1. So when you divide by 0, what's your final answer? Undefined. All right, so we're going to put this on our unit circle. So we're just going to write the tangent values here. Okay, so at 0, it's 0. Here you have root 3 over 3. Here you have 1. Here you have root 3. And then this one is undefined. Okay, I want you to look at these numbers and see what you notice about those values. These are for your tangent. Okay, so look at these numbers here. So you have root 3 over 3, 1, and root 3. The biggest number out of all of these is what? Well, the square root of 3 is between what two numbers? Yeah, we can close it up further. I was thinking like what you're 1 and 2, because what's the square root of 4? 2. What's the square root of 1? 1. So this has to be bigger than 1, right? If the square root of 1 is 1 and the square root of 4 is 2, okay? And then root 3 over 3, this has to be smaller than 2, right? So if it was 2, this would be 2/3. How does 2/3 relate to 1? It's less. So these go in order from greatest to least here, or least to greatest if you start at the bottom. Okay, so that's how you know which one is root 3 and which one's root 3 over 3. Okay, so this is something that you can commit to memory because it just makes sense in terms of the numbers. Okay, but if you don't have it in memory, that's okay too, because you can always find it by doing y divided by x. So based on what we did here, okay, these are the positive values. When we're looking for the tangent inverse of negative root 3, okay, the first thing we're going to do is we're going to think of where root 3 is in quadrant 1. Because remember, everything's going to relate back to quadrant 1. Okay, so in quadrant 1, I know that root 3 is here at pi over 3, right? That's what we just found. Okay, so I'm using my knowledge from quadrant 1 to help me figure out the rest. And I'm also going to use all students take classes. So now I need to know where the tangent is negative. Okay, so the tangent is positive in 1 and 3, which means the tangent is negative. In Q2 and 4. Now this isn't something that you have to write down when you're doing this on your homework, but having these notes is going to help you solidify what is happening with these different patterns. Okay, so using all students take classes, we can figure out where the tangent is a negative value, and all we're going to do is use the reflections. So if I reflect this into quadrant 2, I'm trying to find this value. Yes, 2 pi over 3, because you can just count, right? If this is 1 pi over 3, this is 2 pi over 3. Okay, so that's going to be one of your answers. And then again, we're going to use a reflection, and this time we're going to do the reflection in what quadrant? Quadrant 4. So if I reflect this point in quadrant 4, I'm here. Now there's a couple different ways you can think about that, but look what these two make. What do they make? They make a straight line, and a straight line is 180 degrees, and how many radians? How many radians? Pi radians, yep. So if you take 2 pi over 3 and you add pi, can't we figure out what that is? So think of it as, 3 pi over 3, which is 5 pi over 3. Great. Another way you can think of it is the reference angle, because if this is pi over 3, all you have to do is 2 pi minus pi over 3, which is 6 pi minus the pi over 3 to get that. And then your answer is just written in this same form, okay? So it's 2 pi over 3 plus 2 pi n. 5 pi over 3 plus 2 pi n. So most of these are going to have 2 answers, okay? Most of them will have 2 answers. Some of them will only have 1. And those are going to be special points like this, okay? Because there's only one place where you have a 1 in the y. Okay, so most of those have 2, but not all of them. All right, now we're going to talk about restricted domains. So we restrict domains so we can have one-to-one functions. That way when you plug something in, there's only one thing you can get out. So for trigonometric functions with restricted domains, we use a capital letter. Okay, that's how we differentiate them. These are also called principal values. Okay, these are the principal values that we're going to be finding. Okay, so those are going to be denoted with a capital letter for sine, cosine, and tangent. And they're restricted as follows. So for the sine function, it's the sine of theta 4, okay, and you have negative pi over 2 is less than or equal to theta, which is less than or equal to pi over 2. Okay, so they restrict your values from negative pi over 2 to pi over 2. All right, so I'd like to show you what that looks like. If you're thinking of your unit circle, right, this would be negative pi over 2. This would be pi over 2. So that's going to cover quadrant 4 and quadrant 1. From negative pi over 2 to pi over 2. Sorry, that's minute. Okay, so that means that your values have to be in quadrant 1 or quadrant 4. Okay, quadrant 1 or quadrant 4. For the cosine, we have a different restriction. We have 0 is less than or equal to theta, which is less than or equal to pi. So from 0 to pi, what 2 quadrants is that going to cover? 1 and 2. Great. Okay, so that means your solutions for that one are going to be in quadrant 1 and quadrant 2. Okay, and then the last one, our tangent, is going to be the same as the sine. So negative pi over 2 is less than or equal to theta, which is less than or equal to pi over 2. Pi over 2, negative pi over 2. Okay, so if you're going from negative pi over 2 to pi over 2, it's that part of the circle. That's why I'm shading in these two quadrants here. Okay, so it's quadrant 1 or 4. Now, the reason why these are the way they are, it's based on where the functions are 1 to 1. Okay, so these are based on where the functions are 1 to 1. Okay, so it's not random that these are the restrictions. Remember, if a function is 1 to 1, that just means for every input, there's exactly one output. Okay, so we want there to only be one output here, and that's why we restrict those domain values. Okay, now what we just talked about, a lot of that is covered in the table on the back sheet. Okay, they organize this for you in a chart, but there are a few extensions. So the inverse sine function, okay, where you have that capital letter of sine, is either shown with that -1, or you can also have an arc sine, is what it's called. The same thing happens with cosine. This is arc cosine. And then arc tangent. That's another name for it. Okay, now we're going to look at the domain. So remember, the domain is just your set of input values that's going to produce an output. Okay, it's your set of input values that is going to give you an output. Okay, and then the range is going to be your set of output values. So I want you to look at the domain for sine. Okay, the domain for the sine, it's saying that the values have to be between what two numbers? Yeah. Okay, so it has to be between -1 and 1. Same thing here, between -1, that's my hand, that's my hand, and 1, okay? So in order for you to get a valid answer, if it's sine or cosine, whatever you're plugging in has to be between -1 and 1. Okay, and then if you do plug that in, let's look at our range, or the output. So for the sine, the output is going to be between -pi/2 and pi/2, which is equivalent from -90 to 90. And so we just talked about that. If we're from -pi/2 to pi/2, that means we're looking in what quadrants? Quadrant 1 and 4. Okay, for the cosine, it has to be between 0 and pi. Okay, so again, we remember, 0 to pi, 0 to 180, we know that's quadrant 1 and 2. Okay, and then for tangent, it's quadrant 1 and 4 again. Okay, that's your output. Negative pi over 2 to pi over 2, negative 90 to 90. What we didn't talk about yet with the tangent are the input values. So if you have the inverse tangent function with the capital T here, it says that your input is from negative infinity to infinity. That means there's no restrictions. Okay, or you can think of it as all real numbers. That means you can plug in any number, okay, and you can get an output value there for your tangent. Okay, so using this information, we are going to evaluate the inverse trig functions. And then it says, give your answer in both radians and degrees. Okay, and again, we're only doing this with quadrant 1 of the unit circle. Okay, so we're only doing this with our quadrant here, and I'm going to help you with the patterns. So the first value we have is capital cosine. So the cosine inverse of negative root 3 over 2. Okay, the cosine inverse of negative root 3 over 2. Okay, for our notes, we're going to write down what this is asking us, and then when you do your practice, you don't have to write that down, but it is very important that you understand what this is asking you. So this is saying where in quadrant 1 or 2 is the x value negative root 3 over 2. That's the question that this is asking you. Where in quadrant 1 or 2 is the x value negative root 3 over 2. Okay, so because it's just quadrant 1 and quadrant 2, I'm just going to draw the upper half of the circle because that's my range from 0 to pi. Okay, so we are going to use our quadrant 1 to figure out where the x value is root 3 over 2. How did I know it was the x value? For this cosine. Okay, so if you look at your quadrant 1, the x value is root 3 over 2 at pi over 6 for 30 degrees. Okay, so pi over 6, which is 30 degrees in quadrant 1. So if this is a positive value and I want to find the negative value, it has to be in what quadrant? It has to be in quadrant 2. Okay, because that's where the cosine is negative. So just like we did before, we're just going to use our reflection. So if I reflect this here, okay, I have to find what that value is. You can either count by pi over 6 or use your reference angle. If this is pi and the distance is pi over 6, what's this going to be? Yeah, 5 pi over 6. Okay, so it's just like we're doing pi minus pi over 6. Okay, and then we're going to write that as a degree as well. Okay, so if this is 30 degrees, we know pi is 180 degrees. So what is 5 pi over 6 going to be equivalent to? 150. Again, you can just do the 180 minus 30 to get 150. Okay, so this is going to be your final answer. 5 pi over 6, 150 degrees. Okay, for part B, we're going to find the inverse sine of 3 over 2. Okay, so the question this is asking you is where in Q1 or 4 is, this time it's the y coordinate because it's sine 3 over 2. Okay, so if I'm looking at my circle, I have a root 3 over 2 for y, but do I have 3 over 2 anywhere for my y in quadrant 1? No. Where is it? Nowhere. Okay, so what you want to do here is check the domain. Okay, so you want to check to make sure this is in your domain. So it's 3 over 2. We said the domain had to be between -1 and 1. Okay, so is that in our domain? Nope. Okay, so since 3 over 2 is greater than 1, it's not in the domain. Therefore, what do we think our solution is going to be? Yep, our solution is undefined. Okay, so that is your final answer. Now, you will have a no calculator portion, okay? But if you're doing this in your homework practice and you want to double check, okay, you can check with your calculator. If it's not on the unit circle, and if you get an error in your calculator, you know it's out of the domain, okay? So that's a good thing to check. So if you do the sine inverse, which is right above your sine key here, okay, you can just watch me for now if you don't have this handy. Okay, if you get an error domain, that means it is going to be undefined. Okay, if you were to do like the cosine inverse here, negative root 3 over 2. Okay, see how you get the 150 degrees out there? Okay, so that is a valid place. Okay. Again, you won't have your calculator for your whole test. That's one of the reasons why I can choose it for you. All right, let's try one that's given as the arc value. So this says the arctangent of root 3 over 3. The arctangent of root 3 over 3. Hey, you guys are doing a great job. I know it's a lot of new material. Okay, so the arctangent is just saying the same thing as the capital tangent of root 3 over 3. Okay, so you have to find where in Q1 or quadrant 4, because that's our range for the tangent, is the tangent root 3 over 3. Okay, so if I'm thinking of all students take classes, in quadrant 1 or quadrant 4, if it's positive, it has to be in quadrant 1. That's where the tangent is positive. Okay, root 3 over 3. Okay, and then based on what we did today, do you guys remember where it's root 3 over 3? Yep. So it's root 3 over 3 at pi over 6. Okay, so your answer for this is pi over 6, which is what in degrees? 30 degrees. Okay, and then there's one more type. that we gotta make sure we know how to do. Okay, do you guys want to set up your question this time? Where? See if you can write down what the question's asking you. Okay, so your question should be where in what? Yes, where in quadrant 1 is the tangent negative root 3 over 3. Okay, and you don't have to write these questions out on your homework, okay? This is just to help you with what you're thinking. All right, so if it's a negative, should it be 1 or 4? 4. Okay, so tangent is negative there. Okay. Okay, you also don't have to draw these out every time, especially if they're in quadrant 1. You're going to see that. But I do think it's going to be helpful for you in some cases. For example, we know in tangent 1, okay, this is pi over 6. Okay, so pi over 6 is the root 3 over 3 for tangent. So we're using the reflection in quadrant 4. So we are using this value. Okay, and then we need to be a little careful with this. Do you guys know what this value is here? Yep, so this value is 11 pi over 6. When you are doing the capital tangent, you have to keep in mind what the range is. So if you look back up at the range for the tangent, let's write it down. The range has to be from what to what? So negative, if I look at my chart above, it says negative pi over 2 to what? To pi over 2. Okay, so if it has to be between those two values, pi over 6, or 11 pi over 6 is not in between them, right? This is negative 1/2 and a half. And 11 over 6 is definitely greater than a half, right? So all we have to do is write this as the negative angle. So the negative angle starts here and goes down. What's another name for this angle? Negative pi over 6. Which honestly I think is a little bit easier, because if you know it's pi over 6, then the other one is negative pi over 6. So because this is our range, you're going to use the negative angle. Okay, so 11 pi over 6 is it's not in the range. It's not in your output values. Okay, but negative pi over 6, it's the same angle, it's the same place on the unit circle, but now it falls into our range. So negative pi over 6 is how many degrees? Negative 30 degrees. Okay, so that one can be a little tricky, just making sure that it's in the range. Okay, and then your practice for tonight, it says complete all problems without looking at the unit circle. And you can use your quadrant 1. Okay, so when it says complete it without looking at the unit circle, you can use the Q1 that we made today, or last week. Okay, and then you can use your unit circle to check your work. I also don't want you to miss any points, so I'm gonna let you know that you have to answer this vocab question. It says, explain how the inverse tangent function differs from the reciprocal. How do we write the inverse tangent function? Tan with that -1 value, okay? What's the reciprocal of tangent? The cotangent, yes, okay? So if you guys want to write that on there to help you, okay, I don't skip the vocab if you want all your points, okay?